Hello everyone and welcome to Handmade Hero Show, where we code a complete game live on stream. We're in the thick of it now. We have a bunch of stuff we've got to do because we basically have everything kind of coming together here, and we need to start cleaning up everything and making it reasonable to, I guess, see what the game actually looks like and plays like, right? We finished pretty much all the engine component work, and we know how it all fits together. So now it's time for us to actually start bolting things down and pulling them together, which really has to kind of be done in a bit of a, in my opinion, sort of buckshot fashion, because every little piece sort of has to kind of now be reevaluated a little bit and go like, okay, how does this part want to really work? Let's like define that hardcore now. We know where it slots in, but maybe we didn't know a couple things about it before, but we know them now. And so on. So there's a bunch of things we want to do. One thing that we need to do also is put art in the game, and our circumstances have definitely changed with respect to that. When I first started this, and it hasn't been a priority, putting art in the game is just not important for building an engine, other than just having some test assets. But once you actually start building the game, obviously the art is crucial because everything that you see on the screen comes from the artists, and without that, you have no idea what things are supposed to look like or how they're supposed to behave or anything, because you can't really see what the context is or what things are going to look like. Can't make decisions. Certainly can't make decisions about, say, lighting without putting the art in, right? So one of the things about that is originally I didn't think we were going to have any real direct artwork on the game because I was originally just contracting with Yangshin for it. And she was remote. She's in China. Well, she's sometimes in China, sometimes in other parts of the world. She travels a lot. And so basically what happened there was, just going to be like, send some sprites and we'll just put them in, and it's kind of a hands-off process, and, we just contract for some and then just use them. But eventually we ended up not doing that because she wanted to go work on other things, and Anna was willing to do all the stuff for Handmade Hero as well. So that means we actually have the opportunity to have someone work directly on the art for the game, which is a big difference. Those are very different processes. And so what I'd like to do is I'd like to make it now that we're going to actually start crafting these worlds. It's probably worth our time to go ahead and make the asset system load on demand. Because we now have the opportunity to have someone actually sit down with the game and improve the art based on what they see in the game, which was not really something we were ever going to have before. So I think that's a really big one we want to do. And so if I look at the spread of what we're going to do here, we want to fix the camera stuff to make that be working the way we want. We want to fix the lighting stuff, and we want to fix the art stuff. All of that stuff now can come together because I think we see everything exactly how it is, right? I mean, this is the game now, I think, is clear to me. And the engine parts are clear. There's not a lot of mystery there to it. So I want to go ahead and start to get all of those together so that that can take shape. And the one main thing I think that we want to add, asset-wise, is the ability to do those kinds of loads. So I think it's worth probably spinning through that system and making that stuff work. And it's not that hard to do. We basically have a system currently that loads more than one asset file anyway. So allowing it to on-demand replace an asset is probably not a big deal. Like, there's really just not a lot to it. I don't think that we would encounter there. We already have bitmap eviction and stuff like this. And so once you have those things in place, it's sort of the case that having it load out of a file on demand if we need it to, or something like this, shouldn't really be a problem. So I think that's what we want to do. And we can go from there. Now let's take a look at what that would entail. I'm going to go ahead and do a little build here. And run. So if we imagine what we're looking at here, so of the three things I talked about, the three things we want to do is one, we want to make the lighting bounds accurately reflect what's on the screen. So that's one thing I talked about. The second thing I talked about was the camera. Right now the camera is you can see it sort of working there a little bit, but it doesn't really adjust correctly for larger or smaller rooms and so on. So we want to adjust the lighting bounds, we want to adjust the camera bounds, and then the other thing we want to do is, if we imagined now that we actually do have the opportunity to hand this off to an artist and say, hey, Kira is actually someone who's could work directly on the game, why don't you paint some textures to go on these walls and such. What we would like to be able to do is introduce a key or just automatically reload from disk or whatever, some files that say what the art can be in certain places, and then just have those show up, right, in the game automatically. And we still probably want the game to function the way that it currently functions, where we can ship a asset file that just consolidates things and makes it easier to understand what's in there. So I don't really want to gut what's in there currently. I just want to add something on top that will do that, right? So those are the three things that I'm looking at that I would like to get right now, so that we can go from there and start to focus on actual world gen, right? Because that's the other thing is I need to be able to place like objects and characters and stuff in here as part of the world gen. In fact, I already would like to do that even before we start to get to more complex topology stuff that I'd like to do. With the world gen, even right now we've got an orphanage. We need to populate the orphanage with stuff, right? And at the moment, we are not populating the orphanage with stuff, right? We have no idea right now of what can go in this orphanage. We don't have anything like that. And so we need to sort of get there, right? So these are our tasks. I don't know which ones I necessarily want to do first. I think what I might do is I think I might want to focus on the camera for starters, and just get that working, because we have most of that stuff, and I think we want to just go ahead and finish that up. And then I'll do the lighting bounds while I'm doing the camera. And I won't change the lighting algorithm. Like, we want to go in and continue to improve that algorithm a little bit later on. Like I said, we want to place the lighting points. Right now, they're kind of haphazardly just strewn around the boxes and the level. So we want to like do that a little bit more carefully as well as we go as part of the generative routine. So we'll be doing that part as well. But at the moment, what we want to do is just make it so that the lighting picks the right region, right? Now, we've got some other concerns here that you can see that we sort of have ongoing. If you look at the way that the characters work, even when we put in the new character sprites, I don't know how... I really like the perspective feel that we have here, but you can see there's problems with it. Going through sideways doors, you can see that is just going to produce an unwelcome intersection there, right? And I think we might be able to fix that. Like, we'll see with the sprites, but that's another thing that we're going to be looking at as we... Or I shouldn't say we're going to be looking at. That's another big reason why we want to get some, either final or close to final versions of certain sprites into the game so that we can tune things like that. Whereas right now we're flying blind on some of those things. And now that we've gotten to the point where everything's in place and we want to kind of converge on a game, we can't really do that again, without having really good knowledge of what's actually supposed to happen artistically there, and we need to make those decisions. So that's what we want to do right now, and so I'm going to move through those things. So let's start, like I said, in order. Oh, I forgot I had those keys for changing the lighting. It's kind of fun. All right. So anyway, that's what I want to do. I want to go ahead and push towards that. So let's just take a look at where that sort of stuff is happening in terms of the camera and so on. And let's see what we might want to do with that. So for starters, I was saying the lighting bounds, we know that there's some stuff happening with lighting bounds here. You can sort of see this light bound stuff happening. And you can see that really both of these are kind of ad hoc. So what you can see is we're taking some variable called standard room dimension, and we're just going, well, look, we know there's some size we said rooms were, and we're just gonna arbitrarily like decide that whatever the standard room dimension is, we'll do 3 wide of that, right? But that doesn't really help us. You know, we're talking about a world that's going to have different sized rooms, and it doesn't really make sense as the thing that we want. And the same thing goes true for the light bounds. So like, you know, a trivial fix here is just make the light bounds larger, and then when we run it, you know, we hope that that covers it now, and that's fine. But remember, light bounds are costly, so yeah, now we're simulating more of the space, but we're costing more frame time because we're gathering up more space. And similarly, what you can see is because the simulation bounds are focused on room centers, you can also see during the transition, the light bound is kind of in the wrong place, and we see an unlit region for a little while, right? So all of these things are sort of, you should be aware of, they're not what we want to do. And so, you know, if, for example, I just made the, another solution here, just to give you some examples, is to just light everything that we simulate. Again, too slow, and we're lighting tons of stuff we don't need to light, so we keep impacting the frame rate potentially negatively here and make work a lot harder for ourselves. Looks like we also get into situations where we blow out the size of what we have, right? This, you can't see it, or this is an optimized build, so it looks like it's breaking on a line that couldn't possibly break. But really what we're seeing here is we're running out of room for storing our lights. So we're blowing out those buffers there, right? So again, you know, a solution would be to light everything. Again, we really don't want to do that because then, in addition to having to have larger buffers to store stuff, it's just going to slow us down, right? So what we want here instead is a more camera-centric thing for the lights and a more camera-centric thing for the simulation bounds as well, just slightly different, right? So here we've got this camera bounds in meters situation here. This is the camera bounds that we're saying we're sort of seeing here, right? I don't know, do we draw this? I don't know if we do. Let's take a look, and do we draw any of this? We don't really draw this. So I want to draw this so we can see where it is. So in here, what are we drawing? So we draw the screen bounds, and we draw those in yellow. We draw the sim bounds in cyan, and then a purple region that's the grown screen, the grown screen bounds there. Let me take a look here. Which ones of these we see? So we can see the purple region very clearly, but I don't see any of the other regions. So let's take a look at those. So for example, I don't see the sim bound region. All I see is the world sim region bounds. So why is that? We should be seeing a 3 worlds. It might be because it's right on top. So let's take a look at what happens here. I just want to see what's going on here. So we're seeing the purple one. I'm going to comment this out. Okay, so those are just coincident. So I'm just going to leave us drawing for now. Well, I guess what I can do is use this line to draw the other thing I want to draw. I'm going to leave us drawing the sim region bounds. And what I will do here is I'll draw the light bounds. So that way I can see both of those two things at the same time. So there's the simulation region. There's the region we're lighting. And as you can see, the lighting lines up with that region, so it makes sense, right? And our goal is to never see, while we're doing something like this, that line. And you can see we clearly do see it as the camera moves, because the camera moves in that hop. So you can sort of see what we would like to do, for starters, is slide that region, right, along with the camera. So instead, for example, of the light bounds being centered around 0, 0, 0, we really want them to be displaced by the camera's motion. You know what I'm saying? So you can see here when we're talking about, for example, the camera rect here, where we go get camera rectangle at target. I'm interested to know, in fact, because this has been a long time with the code, we're not drawing this world camera rect, I don't think. And I think we would like to, right? Let's find out. So in here we've got these screen bounds. What I'd like to do is probably push a volume outline for this thing. I'm assuming I can specify one of these rectangle 3s, right? I'm assuming I can pass one of those down and draw it. So I'm specifying world camera rect, and I wanted to see where that is. So you can see, so I suspect, just based on what I'm looking at here, that a big part of our problem now is that that code is obviously borked, right? We probably never updated it. So there's the rectangle I was drawing, and that yellow rectangle must be the screen bounds and so on, right? They're just wrong. And so I think what we want to do is we need to like make that routine actually work. So what we want to do is we want to produce something that draws exactly the screen region based on the current camera view, because that's going to tell us what's in view, and that will tell us what we need to light, right? That's what we're actually looking for here. We want something that's going to tell us that information. So I think where we want to start our little adventure here is probably right there in fixing that routine, because that routine is one that we need for everything else that's camera track related. So let's start with that. I don't actually remember writing that routine. It's been a long time. So let's just look at it. There's probably a to-do in there that's like update to the new 3D system or something like this. And that is exactly what we need to do, right? So here is our unproject stuff. So, you know, it looks like we actually, at least nominally, we're making an effort here, though, right? This is, I don't know, yeah, like how we got away with that, without putting a to-do in there, but pretty obviously stubbed. I like we say get rectangle at target, and we just say that Z is 8, the magical 8. Well, okay. So we have two things to do. One is we need to validate our unproject function. And our unproject function is the function that tries to take our camera system and reverse a projection that goes through it. So we need to make sure that that's working properly. So all of these things in here, right, have to work properly. And these all seem to be written, I mean, I like the way these are written. They're all written in terms of saying, tell me how far out from the camera you wanted me to go. So that all seems good. Yeah, so that all seems good. So really the primary thing we want to start with before we start debugging this, because maybe there's some things we changed in here that make this function no longer accurate in terms of unprojection, so we need to go assess that. But when we look at this, what we see immediately is just that, like, yeah, in order to make this function actually work, we need to actually specify what the target is you're trying to look at. And so in order to get that, we need to know, like, what is that target point, right? Like, how far is that target? So I think what we want to do there is probably just pass the z in, like so. And force the person who's calling us to tell us that what they're actually looking for there. Because if you remember back here where we sort of set up the camera, we know that we are doing some kind of a targeted based cam, and we've got two situations where that happens. One is where we set up the camera to sort of to be a debug camera where we can orbit it around and stuff. And there we definitely know what the target is because we literally move away by whatever the debug camera dolly is, whatever that amount is. So we know that world mode debug camera dolly would be the correct thing if we were using that camera. But that's the debug camera. So the other camera we have is the gameplay camera. And the gameplay camera tells us how far away from whatever the target is that we're looking at that we want how we want to adjust it for where it is in the game. And what we know about that is we don't set that piece of information anywhere convenient. And that's probably the thing that stopped us when we were initially typing this in from doing the right thing there. And we just stuck an 8 in there until we were going to go make that code more correct. So I think what we want to do here is take a look at when we're dealing with the camera. What we want to do is when we update one of these cameras, I think we want to make sure we remember what we were looking at, right? And to the extent that we do, we're okay. To the extent that we don't, we're in trouble. So let's go ahead and take a look at how that actually works. That's stored, I believe, in the world mode somewhere here. There it is. So we've got this game camera, right, stored in the world mode. And that game camera tells us a bunch of stuff. Here's like the target P, for example, and the target offset Z. So I think what we probably want to look at here is this is where the camera is actually at the moment. And so what we want to do, I'm sorry, this is what where the camera is actually at the moment. This is what the camera is trying to look at. And we've got a bunch of Z information here that we should be passing. So I think the goal should be, let's make sure we send the right information down from like the target offset Z or whatever else. Let's make sure we get that stuff in there correctly, and then we'll see what we're doing. So I'm going to start by assessing this routine and see what we're actually setting those values to. You can see in here we set a bunch of stuff, like here's how we figure out where our target is. And then we kind of come through here, and you can see us doing some Z work on what we expect the offset Z of the camera to be. Target offset Z is what I think we're moving to. Offset Z is what we're actually using in terms of our distance off of the floor there, right? And so I think the key here is just to make sure we understand exactly what we're storing for where the camera view comes from. So I just want to pop back here and make sure we've got it right. You can see here we're doing a bunch of work to figure out where the camera is placed. And what you can see here is we have the simulation center for the camera, and we've got the position of the camera, and that's the delta. That delta, the offset Z is just not used here, right? And so the offset Z is an interim computation, and so I think what we want here is to make sure we're recording this value accurately to what we're looking at. So for example, you can see target offset Z being 16 here. That controls how far away the camera tries to place itself from things, right? So if I was to dynamically change this, right? Let's compile the game. We should zoom in, I think. Oops. I'll just pass 8 here again. That's what we were passing before. Right, so we'll zoom in if that gets set to something else. This is what it was set to. And what you can see here is the target offset Z ends up being something that never really gets taken into account there. So it must be where we must take that into account somewhere. Ah, there it is right there. Okay. So never mind. I did do it. When I searched before, I wasn't searching in the right place. So that's where we're setting that camera offset with the offset Z. So that means this value will be the correct value for how far away we are from the thing we're looking at, right? And so now that I've set that, what we want to see is, can we get this box now to be somewhere sensible, right? We want that. We want to now see if we can get the computation of that box to be something sensible. So what we're seeing now is when we call, where did it go? Get camera rectangle at target. We get this world camera rect, right? And we don't adulterate at all. It's just there. And we draw it. So we push a volume outline for this world camera rect at that point. And so what we want to see is we want to see that now encompassing the screen. So we want to see, you know, when we get that, when we make that call, we want to see that rectangle inscribe the screen, assuming we draw it at the center point that we're actually looking at, right, at the target P. Which at the moment we would be, once the camera settles, we would be, right? So I think that's all we should need to focus on now. So moving back over to the render group, when we're calling this, so when we're calling this, the question is, why are we not getting reasonable results back from this call? So the game xform, we assume, is set correctly at the time that we make this call. Now, maybe that's an incorrect assumption, but I think it is, because right here we call set camera transform, and what you can see here is this call right here, especially when we're not using a debug camera. But I believe the true and the false control whether it sets the game one or the debug one or whatever, right? Oh, no, sorry. That's camera is debug. That's what that is. Right there. So it's this flag, right? So when we set that, this right here should set that game xform up, and that's what we should be pulling from. So I believe this will be unprojecting with the correct things, and you can see us sending 0, 0, and then screen dimension down. Now screen dimension, I don't really remember when we set that part either. So, you know, that could be an incorrect value that's being set there. I'm not sure. So first thing we might want to do is take a look at what's going on there. But assuming that that was passed correctly, then when we do our unproject, first thing we're unprojecting down is 0, 0. The next thing that we're unprojecting is the screen dimension, so the two sort of corner pieces. And we're unprojecting down where they would be in terms of like out in the at that distance from the camera. So when we construct our probe Z, what we're doing here is saying, well, whatever the world distance is from the camera, we're going to go ahead and try to inverse transform those points. So here we're saying, we're taking the render transform and we're looking at the z-axis and we're multiplying it by the z-axis. That's correct. That's how far we'd be going, right? And then we're subtracting that from the transform p because we're going out the negative of that, and that's the place we're starting from. That makes sense. We're doing the forward projection of that out into the world. All right. So basically what we did is we produced the clip value for a point that's just that far away in Z. Seems reasonable to me, actually. We take the screen center. We offset the XY value we're trying to actually compute. We offset that from the screen center. We then produce the clip space X and Y by scaling that right out so that we're producing the unit rectangle there. We then produce the clip coordinates and we project the clip coordinates back through the inverse projection matrix to get the world location. So what I would say about that, though, is it's not quite correct, right? Because technically that wouldn't produce the world location. That would produce the world location if the camera had not moved anywhere, which I guess that's what we're calling it. So, I mean, it is a world P in that sense because we're centered around 0, 0, 0, so I suppose that's okay. But that does seem pretty reasonable. I'm interested to know what screen dim is. Oops. So it's just the pixel width and pixel height, which is what we would expect. So that all seems good too. All right, so I don't see any obvious problems here, so I'm going to go ahead and do a debug build, and I'm going to step in, and I just want to look at what happened. So now you can see that as the frame rate slows down, you can see this is now the debug build, right? So let me go ahead and go into the debugger, and let me step into that specific routine, which is really only called there, so we know that that's what it's going to be. So the distance is properly passing just about 16. It hasn't quite converged on it because of the bad way we wrote our interpolator. There's a to-do about that. So 16 is what we expected to see there and do see, so that's a good thing. So let's look at how the minimum corner is projected out. Here we are in the unproject function. So I'm going to take a look at these and see. So pixels x, y should just be the 0, 0 vector, right, because we're trying to the upper corner of the screen. The world distance from camera Z should be that 16 value. And then the X form should, oops. Didn't want to do that. I don't know why they did this. In the new version of Visual Studio, they made it so return doesn't go to the next one of these. I have no idea why they would do that. It's so annoying. I have no idea why you would do that. But they did it. So in here, we have the transform. It's a little bit hard to see because of the way that it's laid out here. Unfortunately, Visual Studio doesn't have a matrix view. It should by now, you'd think, but it doesn't. So yeah, they were too busy making it so that hitting return doesn't go to the next line. So anyway, when you take a look at what's going on here, what you can see is that our X coordinate is unadulterated as it passes through for the world transform. And then our Y and Z is rotated like this a little bit, which is exactly what's like. But for the most part, and this is good, this is the identity matrix. So really nothing is happening here. You know, this is effectively a non-transform. It's only this piece here that's relevant to us. So what you can see, first of all, is when we do our transform here, the Z value there sort of helps tell us how we were marching out along the Z-axis. We're going to go straight down Z, and when we add the offset, we're basically just going to add a 16 to it. So what's going to happen here is our probe Z is going to basically come out to be a 0, right? Because that's exactly what we expect to see there. Let me put that down here. So looking here, what you can see is this is basically the 0 vector, right? In fact, if I do it like this, you can see a little bit easier. So 0, substantively 0, right? It's an E negative 7. So that's a really low number. And then the Z of 0. So that's also what we expect to see. Because from the camera, if we step out that far, we get to the 0 vector there. Now, part of the problem, though, I think with the conceptualization of this, if I may, is that I feel like this routine, I don't remember when we wrote it. I feel like this routine has its head a little backwards here, because on the one hand, it's talking as if the camera is already the center of the world. On the other hand, it's adding this offset here. And I'm not sure why it's doing that. I don't think that's correct. I wish I could go back right now and watch the video where we wrote this routine, because if you think about how this is working, it's constructing something relative to the camera here. I don't know if we did that as an optimization of what we were trying to do or something, but it seems like that should be happening after the fact, right? Like this should be placing things into the world by taking into account the transform of this stuff after the fact. I would have thought would have been how you would do it. And maybe we were just really clever here, and this is actually the correct way to do it, but doesn't seem like it. And just to be a little bit more concrete about what I'm talking about, so if you imagine what's going on here, I would have expected to see something more like this. Yes, there are clip coordinates. Yes, they got transformed by the inverse transform. But then after that, I would have expected to see this. So the world P, this is actually, like I would have expected to see something more like this, right? So there's a camera P, and then there's a world P, right? And the world P takes the result of the camera P, which is in camera space, and puts it out into the world by actually like placing it through the forward transform. That's not what happened here, and I don't know why. And so looking at this, I'm just a little confused. Was I clever? Was I too clever? Was I just wrong? So who knows what happened here. But if you take a look here when we're actually doing this computation, so what I would have expected is the z value is the world distance from the camera that's being passed in, should just be how far out from the camera we go. It wouldn't take this into account. Instead, what it would do is just start with thinking you were this far down the line, and you would go from there. So for example, when we create this V4, that's the probe Z, I would have expected to see that clip coordinate just getting added onto yeah. Yeah, I'm just not sure what that's trying to accomplish there. It also seems like that was sort of, yeah, well. So let's think about this here a little bit. Trying to think of how I want to approach this. Because the other thing that you'll notice that doesn't make a lot of sense to me either is that box that we're looking at in terms of where the camera transform thinks it is there. Let's. Was square, which also doesn't really make any sense because in theory the aspect ratio should have been factored into this as well. And so the fact that it wasn't is a little confusing to me. And I don't really understand why that is happening. So yeah, just a lot of confusion here on my part that needs to be dug into. Anyway. So yeah, working out the math here. This is always the hardest thing to do on stream because it's difficult to work through complicated things like this and talk through it correctly. Yeah, I would expect to see something here that applies this transform. The reason that I know that that kind of has to be the case is one of the things that you can see in this situation here is that the x and y axes aren't taken into account at all in the unproject, which certainly can't be correct, right? When you go to unproject something, you have to take into account the x and y axis, and the fact that that was not happening is pretty obviously busted. I guess it's the probe Z part there that was trying to do that. So let me see, maybe I can think of how this is actually supposed to work. So when we take the probe Z, we're going ahead and taking the probe Z this is actually out in the real world, literally where the point would be relative to the camera. It's multiplying it by the forward rotation matrix here. So it's rotating it also to point in the correct direction. And then it's looking at the clip Z of that as being the z over the w. Now, the w in this case, oh, so, no, sorry. It never actually, yeah. I'm sorry. This is the wrong value here. I wanted the world transform. So we have the projection matrix here, and here's our actual render transform P, X, Y, Z. I guess, oh, so maybe did we smush everything down into that? Is this what we're actually loading? So does that have everything in it? If that's the case, I may stand corrected there. Let's take a look. Again, this is a little bit of code archaeology here, just trying to remember exactly what I was doing. Okay, so I was, for some reason, thinking about that a little bit backwards. It looks like, yeah, so it looks like we're actually, these matrices are actually the whole deal. They have everything baked into them. So that's actually the projection and the transform. Like, it's what we would literally load into the vertex shader, right? So I take it back. It's not as weird as I thought it was. So that makes a little more sense. So then what we're saying here is this right here actually puts us out at the location in the world that we should be, right? We're saying like, okay, here's going from the camera location out to a particular place. We're then multiplying by the forward matrix to put ourselves into actual projection space, meaning where we would be in the world of the camera. And then we're taking the Clipsy value from that. So this is not as crazy as I thought it was. For some reason, when I saw projection, I was actually thinking that that was just the projection matrix, not the projection matrix and the sort of model view, if you will, combined together. So that's okay. And maybe I'll make a note of that. Just so I don't get confused again, when I look at that, I can see a little bit more quickly what's going on there, and that seems like a better idea. Okay, so yeah, so this makes a lot more sense now because this actually constructs exactly where in the world you would be at the end of the day, and you can see here that we're constructing the Clipsy by doing the divide the opposite way there. And so that seems reasonable. So when we do the reverse projection, we should get the world P here. There's just one weird part of that, which is when we do that, just want to make sure we're doing everything right here. Yeah, when we do that, we are processing the correct values through. So, okay. All right. Okay. So I'm more comfortable with that now. I'm not as scared of it as I was originally. Let me go ahead and allow this thing to run down to where we're looking at it again. And let me run through here and take a look at these values now. So now that I'm more comfortable with what I'm looking at, the probe Z value that we get out here after doing the forward projection is 0, 0, 0, right? And let me just let me jump in here one more time. So when we first construct it, it's basically all zeros. When we go to do the forward transform, I would expect this displacement to take effect, right? So there's a displacement of 10 on Z there. There it is. Okay, good. So I wanted to make sure that was there. When we compute the clip Z, that's not really coming into play quite yet. Let's take a look at the screen center. Screen center seems reasonable. The clip space XY, that seems reasonable. Let's make sure these convert to the unit rectangle. They do. And so now when we produce that clip value, that seems okay. The only thing I'm not confident of is the clip Z. So what will happen normally is when you do that transform, what you would normally do is you would take the value that ended up going into the W coordinate and you divide everything by that. So I'm not really sure this would be operating correctly. So that seems erroneous to me. The reason that seems a little erroneous to me is because the synthetic divide is the thing that maps things into perspective. Doing it here produces the perspectively divided Z value, but in order to get that perspective coming out at the end, you would have to do another divide here, right? So you can't. This seems a little backwards. There should be a divide happening here to undo what would have been the perspective divide. Like, basically, this is missing a divide, I feel like. It's missing a multiply of an inverse over here, right? Stuffing the clip Z value into here is not correct, I would argue. Because this multiply is not going to do a divide. This is just going to do the matrix multiply. That's all. So I think that's the problem with this routine, is it's not, although it is going to great lengths to produce a clip Z value that is the correct value that Z would have after transform, it doesn't matter. So this divide, first of all, I don't think this divide should be there, because again, why would it be there? That divide would just have to get undone before the inverse projection happened, and then when the inverse projection happens, again, this divide should have happened before then, because these are post-divide numbers. Am I wrong about this, guys? you know? So it seems to me like that's kind of misguided. It seems like it's just the z value. And then when it gets reverse transformed, it should just be using that value. And the w value is what should actually control these things, right? So in here, before these go through anything, it's really, this value should be undoing. You have to imagine that these values were divided by probe z.w in order to get into the clip space the way they were, right? So what we really want to do there is invert that operation, meaning that like the clip space xy.x should be multiplied by probe zw as the first thing that it does, right? So that, it seems like this was doing that exactly backwards to me. I don't think that's all of our problem, but that was definitely a problem. That was not good, what was happening there. Yeah, and that's all I can really say about that. So the first thing that I'm still noticing here is that I never see the white rectangle, and I don't know why. I'd like to go make sure I understand why. But what you can see now is the yellow rectangle there that's being drawn, which, let me just show you where that was being drawn again. It's right down here. So the yellow rectangle is being drawn here for the screen bounds, right? And the screen bounds are, again, built off of that world camera rect. What you'll notice is those are the right size now. So that change I just made was, it did exactly what I thought it did, meaning the code was doing exactly what I suspected was wrong. Because now we can see, A, it's rectangular, which is what we expect, and B, it's the right size again. So this is correctly noting, when I come back to the screen view, let me kind of come back here, you can kind of see that it's correct now, its size. Now, it's not facing the right direction, but it's not supposed to, because the screen bounds are by definition flat at the moment in that space, because you see we created them flat. So it's not its fault that they're facing the wrong direction, but it's getting the correct size now, and that's what I wanted to see there, right? So that's good. You know, that's obviously a good thing. But I don't understand why I'm not seeing my other rectangle. That's a little weird. So we did our world camera rect here where we get the camera rect and it comes back. And then I tried to draw that here. And I'm not seeing that thing. This yellow rectangle here is just a 1x1 cube in the center. I don't know why that's there, and I'm going to get rid of it. It's not useful to us. But this white rectangle here is not showing up, and I don't really know why it's not showing up, because it should be somewhere. And the fact that I don't see it anywhere is a little disconcerting, and I don't really know what's going on there, because especially now that I know that that thing is the correct size, I don't really understand. Okay, so you could see it was kind of off in the distance, is what it looked like. It looked like it was too far away somehow, and then it faded out. Now, in this mode, I feel like there shouldn't be much fading, so I don't, because there it is. So it looks like the problem with that thing is it's been placed way in the wrong place, right? It's the correct size, but it's placed incorrectly. And I don't know why. So that's the next thing we got to figure out is what's going on with that, right? So again, baby steps, but debugging something complicated like this, it takes a little while. So this correctly accounts for what I thought it needed to account for, certainly. So that's good. And when we're producing the world P here, you can see us do the min corner, max corners. Sif here producing that result. So the question now is, why is that offset so dramatically? And how could it be offset so dramatically and still be producing the right size? You know? So that's a little interesting. So let's go ahead and step through that code now and see where we're going wrong with our offset. It seems like we're offsetting Z quite a bit too much. And so I must be missing one more subtlety about the way this is constructing the code. So the first thing I'm going to do when we run through here is I'm just going to go ahead and set a breakpoint in and see. I just want to see when we actually do one of these. Oh, that's the mouse. I want to see what we get. So if we take a look at this, we get negative 26, negative 25. Given that we're 16 away from, like, we're 16 units away, am I wrong about that? Given that we're 16 units away, it does seem odd to be getting a number that high, right? We're getting exactly the right numbers out of X and Y, but we're getting the wrong number out of Z. And so maybe I'm thinking about the way that that Z value comes out of the forward projection. Maybe I'm thinking about that incorrectly there. And you know what? I might be, because the convention for how the Z comes through is going to be that the Z needed to have the W value pushed into it so that the Z still comes out for Z buffering. So it could be that that does need to be divided by the W. It could be that this clip Z computation was correct and it was just this part that was missing. But I want to think that through a little more. So I'll test that to see if I'm right about that. But then we got to go look at that. I want to look at the projection matrix again, just to see whether the projection matrix is actually computing that way or not. If it's not, then I'm wrong about that. And even if this works correctly, I'm still wrong. So there's that. I'm wrong about the reason. So it does look like that's the case. And so now rotating around, it does look exactly like what we would expect now. So that now seems totally correct. Okay. So I'm guessing that what we do is we multiply the, yeah, okay. So what we did there is in the projection matrix, we should see the W get multiplied into the Z because when we divide by W, we want the Z to come out to be the same value it used to be, right? So we should see that. If I go to the projection matrix code, I want to see that now to confirm that I'm correct, because don't really want to just have the code work but not know why. That's a bad place to be in, especially with complicated stuff like this, right? So I want to see here, I want to see matching computations basically for how W and Z are computed. So what we can see here is in the forward transformation that we're applying, and this is just the perspective projection part. That's the only part I'm talking about. I'm not talking about the rotational or displacement aspects. Don't care about those at all. So I'm just talking about the projection. You can see that we're getting negative Z in here as the W value. So we're going to be dividing by negative z. And we want the z value to come out to something specific here between the near and far clip planes for distance, right? In fact, now that I look at it, so these values here, world distance from camera Z, actually should be adjusted by that near clip plane value as well. And it will be because of this forward projection, right? So that's where that will take place. So then when it comes out here, we have the divide by Z baked into the E term here. Right? We know that this will come out between those two after being divided by negative z, which means that the negative z was multiplied in. Yes. Okay. So I am fairly satisfied with that now. Okay, I'm fairly satisfied with that. I'm happy with how that went. So I'm going to go ahead and just verify now that that moves with us as we go. Yeah. Okay. So now the next thing that I think we want to do, again, to get the sliding behavior that I wanted, is that does not take into account the camera displacement. So if we take a look at what happens here, where we do the world camera rect, you can see here that we just do the offset z. We need this world camera rect needs to be offsetted by the camera itself's offset because it's going to be moving, right? So we have this in here, this right here, right? Camera simulation center and camera P. We have sort of this delta offset that we set up where if we are to render around if we are to render around 0, 0, 0, it's got this offset baked into it, right? So we need the delta from sim value since 0, 0, 0 is going to be the center of that simulation, we need the delta from sim value to be baked into our world camera rect, if that makes sense. So we effectively need to say that the world camera rect, which is giving us what it would be if we were centered around 0, 0, 0 for the camera looking down. We know we've got an offset in there that pushes us up. We need the opposite offset in there, right? So this, which has the complete camera offset baked into it, although unfortunately it's got rotation as well. Just to give you a little bit more understanding of what the problem is here. So when we set this camera transform, when we get the world camera rect back, we're then going to draw it again through the same camera transform. So we have to make sure that the values that we're passing through here are completely right. Although, now that I think about it, since it's already set, since this camera transform is already set when we do the multiplication, this should slide with it. when we do the world camera rect. So I am not sure why it doesn't. Let me double check. So this is why. Let's take a look at that. At least I assume it's fine. Let's take a look. Well, maybe not. If this is just doing a regular world transform. So yeah, so what I can't quite understand there is why we're getting the world camera rect jumping when we move, because we shouldn't be seeing that, right? That's the only thing that now I'm not quite sure on. So this white outline is supposed to be directly what we got as the world camera rectangle. So while the sim bounds, while the the screen bound, which is reconstructed at 0, 0 every time, should totally do what it's doing, right? That yellow should be jumping. The white should not be jumping. The white should slide with the camera. And the fact that the white isn't sliding with the camera means something's wrong there. Because we get it, we are setting the transform and then getting the world camera rect out as a function of whatever is set as the transform at that time, right? So I don't understand why we would be seeing any jumping when the camera when the camera sim center is moved, because the camera sim center should be like unrelated to what we see with the world camera rect. Now, maybe like this push volume outline thing with the world transform, maybe that's doing something weird. And I can go in now and take a look at that and just make sure that I'm not just forgetting some extra sauce we have there in the pipeline that explains this situation more forthrightly. But that's the thing that's the last thing that's concerning me right now. I want that file. So here with volume outline, so there is no offset P baked in here, which is good. So I don't see the like the place where that jumpy displacement is coming in, right? So that's a puzzler for me. That's a puzzler for me. That is definitely, because so even stuff like this, which this alters where the camera is every frame, but we don't reset the transform. So, you know, from you know what it could be? Well, no, I don't know what it could be. So I feel like we've done most of the work, but we're still just a little bit off, and I do not know where that is coming from. But we definitely have some explaining to do here. That needs a guarded divide. Do we have a safe ratio function, by the way? Yeah. So yeah, what could be causing that? Essentially what I'm seeing happen, and I just don't understand the reasoning for it, is it's positioning the white rectangle as if the white rectangle were not called every frame and based off the camera position every frame. But it's supposed to be, right? It's supposed to be taking into account the full camera transform. It's using exactly the camera transform as specified. And so I'm just not sure exactly why it wouldn't slide along with the camera every time. Now, if I look back here at it a little bit more closely, what you can see is it is sliding. It's just sliding very subtly. And I suppose I could believe... I can't really believe that. I was going to say that we just have the X and Y's wrong on some kind of gross displacement level. So I don't know. I'm puzzled by this. I have no good ideas about why that's not moving. Because the coordinates that come back from that call should take into account the location of the camera. Let's take a look one more time. So as you can see here, when we compute our probe Z, we compute that using the full transform forward. Right? There's nothing weird about that, I don't think. You know, I don't see anything odd there. when we do the inverse transform for our clip space coordinates, that all seems totally above board. I mean, so that definitely seems like it's in the right position. And that min and max seems perfectly solid. So yeah, I mean, all of those things are done with the actual projection matrix and include the full 3D displacement of the camera in the world. And so the thing that I just cannot wrap my head around is why it would seem to be tied to the sim center, right? Because that's what it looks like. It looks like it's tied to the simulation center, but I don't know why. So all of these, you know, these make sense as to why they would be tied to the simulation center, because they are forcing their center to be at the simulation center, which is 0, 0, right? And then they're just using the boundary value to determine how expansive they should be. So that seems totally plausible and reasonable, you know? But our world camera rect should not be centered around 0, 0. It should be centered around wherever the camera happens to be. Although, now that I think about it, well, no, I'm going to stand by that. So it should not be centered around the 0, 0 coordinate system in any particular way. Yeah, so I stand by that. The world camera rect that we're computing here should not be related to the simulation center, because it really just doesn't care, as far as I know what that is. So that's the part that I'm having trouble coming up with. How is the simulation center ending up getting baked into here, essentially? Or is that not really what's happening, and I'm seeing something that just looks like that's what's happening? And there's actually some more subtle bug in how we're producing those unproject calls. Because that could be, I'm totally willing to believe that is possible. But that's the thing that's making me weirded out, right? Is that just really shouldn't be possible. So if we think about how this is working, you know, when we do the entity update stuff, so, you know, when we do this, what you can see here is we set the simulation center by taking the actual place we decided the room was, right? And we set that up as where we're going to make the basis of our coordinate system, and that's great, right? But what you can see here is when we actually set up the camera itself, what we get here, let me look at where the camera offset variable comes from here. Yeah, so the camera offset is just some distance above what's going on, but mostly the delta from sim here, this delta from sim is what's allowing the simulation center to be offset from the camera. And so 0, 0, 0 is over there for that reason, right? Because we subtracted from this to this, and then we use that delta from sim as what we're actually passing here to place the camera in an actual location, right? Here's the place that we're actually zeroing the camera to. The camera offset, right? And so once we set that camera transform, that value should be baked into the matrices. And when we do the unproject, the points we get back should be in world space at a place where, when retransformed through here, should be right where the camera actually is, not where the simulation center is, which should be unrelated. So it seems like we're missing that information. And maybe the answer is we're missing that information in here, right? So maybe the answer is the unproject is not actually properly displacing things by the camera transform somehow. And I'm totally willing to believe that that is the case. I'm just not seeing exactly how. I mean, one way that that would be failing is if the inverse matrix doesn't properly have that information in it. So, I mean, anything's on the table at this point, but if the inverse projection matrix was wrong, there's your answer, right? So let's take a look. So in order for it to be correct, well, we can see it right here. We're doing the verification that it's correct right here. And so if we look at that, we should see that come out to the identity. Let's do it. So if I look at this right here, this is called a set camera transform, I should be able to see that inverse and whether or not it gets set properly. So I'm just going to jump right in there and do exactly that. And what I'm expecting to see, if there's a bug, is that the identity matrix will look like the identity matrix except for an incorrect offset. So in the offset column, it would be wrong. Now, what I don't know is where this actually gets created. So camera C inverse versus proj inverse here. Camera C is something that gets set up here. I don't know what that does exactly, right? Looks like here we're testing this in here as well. Let's take a look. I mean, so that looks like a totally reasonable inverse, right? And so does that, right? So those inverses look really good. I don't see any, like they're, you know, anything you do in floating point is only going to be good to 5 sig figs or so, right? So the -8, -7, -6, those are all well within tolerance of what I would expect. So there's nothing that looks out of place there to me at all. So let's go ahead and test the case we care about as well. So as we run through here, I'm going to hop up, and then immediately when it switches over, I'm going to go ahead and switch over to break. So as I step in here, I want to look and make sure that, okay, maybe when the displacements get higher, maybe we never checked the camera transform there. So I'm just checking it again. And again, what I want to see here is, you know, I want to see that camera P being high, right? It's really not that high. So that's a little unfortunate. I feel like it should be higher than that, but, you know. And that still looks totally good. So here's one that has a big move to it. So again, I just want to take a look, see if I can catch anything here that looks suspicious. Is it that just, it seems awfully low. Is it just me? Why is that so low? I feel like the camera displacement should be quite a bit higher than that. I don't understand what I'm looking at here. I mean, it moved several... It should have moved like quite a bit, unless a tile is only very small. Seems a little weird. I mean, if a standard room dimension is 12, then moving one room up should be like 6 at least. So why is that value so low? Like, what's going on there? No camera offset but Z, that makes sense. Delta from sim, super small. Just how, I don't understand, how is that possible? How are these so close together? Something's weird. Something's fishy here. But I'm not sure what. You know what I'm saying, right? That number is just really tiny. That number should be much higher. There we go. All right, so that's a much higher number now. So now let me look. At what we produce here, just to make absolutely sure this is right. Yeah, so it's stable. The inverse is stable. So that's good. I still think I'm a little suspicious, but yeah. We do need to cap our frame rate at some point here. All right, so when I come out through the top opening here, I'm going to go back and, yeah, switch right there, just to make sure that this value is higher. I do not understand how those are so low. All right, so I want to investigate this a little more because I'm weirded out now. So there's obviously something I don't understand about the way the system's working, which probably means it needs to get cleaned up, which is good because that's what we're doing. But it also means I need to investigate a little bit further. I want to see this value. I want to see it drawn. Like all the time. So here it is, right here. Okay, so it just must have been the debugger, like we just weren't be able to break quite right, because those are the values I expected to see, right? Those are the values I expected to see. And so now if I look here, you can see that the camera box does converge with that value. It just isn't moving nearly as much as it probably should be. Right? So it's as if those X and Y values are not being displaced by the amount they should be. So for example, it's as if the unproject in here is not it's like that value is not doing the displacement. Or not doing enough of the displacement. I mean, I think that's the only explanation for what we're seeing. Meaning when we do the transform, the displacement values in the other part of the matrix are not getting applied properly. But again, I'm just not sure how that's not happening. So what you can see here, right, is the full transform. When this gets activated, the key part here is the The W value is multiplying the displacement value. Right. Okay. This could be our problem right here. The W value needs to multiply the displacement values correctly, and we didn't put in a W value. We put in a W value of 1, but the W value isn't 1, right? We know it's not 1, it's probe z.w. And that W will multiply the displacement part of the matrix, and since the displacement part of the matrix actually was getting multiplied by 1 rather than something else, it could be that it was supposed to be something much higher, which would account for the less displacement, right? So what we need to do here is we actually need to do that to get the full transform out, and then when we're done, we can truncate it down, because now we don't care what the W value is that comes out, although it should, the W value should come out to 1, right? I'm missing a comma. Ooh, that was a nasty one. That was a nasty one. All right, so we're still not quite out of the woods yet. Looks like we've got that slightly backwards in there. But I think now we're at least on the right track, right? So our clip coordinates should have, after the transform going forwards, we should have the correct probe ZW here. And furthermore, now I think this part could be rethought. Because now with the correct probe ZW in the W slot, I feel like clip Z should just go directly into that slot. Like I thought before. And talk myself out of. Yeah. Ooh, man, that was tricky. All right. But now, just in the nick of time, as the Q&A buzzer approaches, we have debugged the problem now. And as you can see, now it properly tracks the camera exactly as it should track the camera, which is what I wanted, which means that now, if we want to, we can get rid of our lighting bug and start to correct those visual glitches, because now with the light bounds, here what we can say is we just do the world camera rect now, and then we just have to adjust the Z, because right now that's not going to be right. So what we were already doing that, looks like, right? So now, in theory, what we should have as we walk around is we should never see any more lighting glitches, right? Our camera's still borked, but our lighting is never wrong. And hey, that's what we're seeing, so that's good, right? So that's really great. Now our sim bounds are a little small, it seems like. They're clipping stuff out pretty early there, it looks like. But our lighting now correctly tracks the camera, which is what I wanted. All right, so now we'll go to a quick Q&A. Got to remember to have our generator generate some lights. You know what I'm saying? Jim Zero, oh, how would you obfuscate what's outside the view of the character? So you mean to say, like, if I was like in this corner, for example, so I can't see out here, like meaning the character couldn't see what was happening here. What would you do if you wanted a game like that, like Fog of War, basically? Um, there's two parts to that, so I'm not sure which one you're asking about. One is how you apply some kind of graphical situation to it so that you know, how do you render something that's supposed to be like sort of only semi-visible, meaning the player can see maybe the structure of it, but not what's there in actuality, or what, you know, moving things would have happened. And the other is computing the visibility. So computing the visibility in our world is actually relatively complicated because we allow pretty much anything. Right now, we happen to be placing things in a fairly grid-like fashion, but we're under no obligation to do so. So visibility computation would actually be very hard in this game. I don't know how you would really do it. You would probably have to do some pre-computation to make it feasible, but we already do it for lighting. So you know the basics, right? Like just figuring out what's seen from what else is just a stochastic raycast, right? So what we could do is start at the hero and cast out lots of rays from the hero and see what we hit. And that would tell us what of the game was visible, right? We could start with something like that. But typically the problem you get is it becomes pretty difficult to do that kind of a computation. So you oftentimes need to have some kind of acceleration, either by cheating, right? Which is to say that maybe what you do is you actually restrict the game to a tile map so you can do some kind of flood filling of the tile map in a more predictable fashion, and don't allow arbitrary geometry, or you you know, introduce some other things like some volumes that help you or whatever, right? Like something to cheat with. And which one of those is appropriate kind of depends on what kind of game you're making. Our game does not have Fog of War, so we don't care. But you would have to make it a consideration and possibly restrict some of the things in the game to allow you to do it in an efficient fashion. Vaterfout, do you plan to close the orphanage's rooms, or do you want them to have the skylight as some sort of ambient light? I'm not sure. We may we'll probably stick roofs on them. Does the update and render function do any rendering right now, or is it offloaded some other place? Well, rendering is sort of deferred at the moment in that it builds buffers so that the GPU can render. So update and render is really the thing that just produces buffers that will later get processed. When we say update and render, what we mean is prepare the things that instruct the renderer what to do. Jim Zero, would you, for example, cast rays to see if something is visible to the character, e.g. if something is on the screen but the character should be blind to it? Yes, and again, like I said, you can do that in a couple of different ways. It depends. If you only wanted to know like whether the hero could see monsters, specific monsters moving around, then what you could do is a little easier because you could just take each monster and raycast to the monster, right? And that makes it a little easier. But if you are trying to do something more like what parts of what squares can the hero see, then you've got a harder problem. And maybe just a stochastic raycast every frame where you shoot out like 1,000 rays from the character every frame and use some kind of decay on what they hit. You know, maybe that's the answer, kind of like what the lighting system does, but since you only have one point of visibility, it's a lot more efficient. So 1,000 rays is not hard to do, you know? So that might be your answer there, I'm not sure. Would Handmade Heroes chunk offset work in 3D? Would there be any problems that I'm not seeing? Well, the game is 3D, so I'm not sure what you mean. Like, it works in 3D because it is right now literally working in 3D. Sergeant Rumby, is there already new artwork to put in the game in the next couple of episodes? Yeah, when we get ready to do that update, I don't know when I will be putting in exactly new artwork or anything, but I want to make the changes necessary to have that happen because I need to, as we start converging on stuff here, I need to have the actual look of the game start coming together so that I know how to make certain decisions about like the rendering and stuff and how that's going to work. Really, my only concern currently, because I like things as they are at the moment, my only concern currently is just this problem. The problem of how to deal with the perspective. And I don't know. It may just work. It may not. I asked for the art to be drawn very top-down, but it's still not quite completely top-down, because if it's completely top-down, you can't see faces, which is a problem. So it's still a little bit not that way, and I don't know if it's really going to work. So it may be that we kind of have... I'm sorry, I just don't know. That's the... It may be that we need to change that, you know? It may be that we have to go with a more direct upright isometric. Like we may have to tilt things so that they're orthographic upward in order for the art to work okay, you know? And that'd be a bummer because I really like the perspective feel. I feel like it adds something to the feeling of the world. But if it just isn't feasible, then it isn't feasible, you know? And we can switch to either of those two. If we need to, so. Yuhi, is it currently possible to easily customize rooms, e.g. with non-random tile Z, etc.? Yeah, you can have non-random tile Z if you want. We just have a random... Right now there's a random displacement in the thing that creates a room. So obviously it's pretty trivial. Jesse F. Sorry, I mean to say if we wanted to make a universe scale game, i.e. a space sim, would that scale well? Yes. The only thing that I would point out is that you may want the chunk dimensions to be much larger. Right now, we keep the chunk dimensions small because we use the chunks. We didn't want to introduce two separate schemes, the entity partitioning and the chunk offsets. But if your goal is to make a giant game world, like if you imagined that Star Citizen was actually working, and you're making something like that, you might want to allocate effectively more space in terms of your coordinate system. So you may want chunks to be much larger, right? You might want a chunk to be a kilometer by a kilometer, let's say, is a chunk, instead of a meter by a meter, right? And so when you do that, you will then need additional spatial partitioning inside chunks, potentially, for other purposes. And again, that just depends a lot on what you're doing. So how the scheme breaks down is largely going to be based on that. So to give you some perspective on how that's going to work, if you actually look at the world stuff right now, what you can see here is that we have this stuff set up, right? That gets the chunk positioning stuff, And this chunk dim in meters is what we're looking at, right? So if I was to stop the game somewhere and look at the world, it should have the chunk dim in meters specified, right? And so here's the chunk dimension in meters. It looks like 23, 12, 5. That's the size of a chunk, right? So then you can figure if you want to be safe and have like reasonable bounds, let's say, then maybe you have 1 billion times that. So you would have 23 billion meters. So 23 billion meters would be like the span, the width of your universe. And 23 billion meters may not be enough. I don't know. Right, so right, you don't want that, right? Like that's not sufficient. Because you want to have like things that are very far apart. So maybe you want you would fundamentally want to change the system a little bit and say, look, let's actually have the internal coordinate system and the external coordinate system scale a little bit more dramatically, and let's have every integer coordinate represent a much larger area, right? That's what I would say. Now, granted, you probably don't want this to actually be the case, because if you actually let this be the case, it would take players forever to get from one place to the other. So usually you would have to warp anyway, at which point, why not just have each one of those things be a separate region that isn't actually connected? So there's a sort of separate issue there. But, you know, it's just worth looking at. So, right, so if it's 146 billion meters from the Earth to the Sun, then that means that you want to probably have your coordinate system be based more on this stuff and possibly have like a more multi-resolution scheme to it, right? If you were actually trying to represent the real universe. So I don't know. I would also say that if what you were doing is trying to represent the entire universe in real terms, you may just want to go with doubles, because it depends on what kind of computations you're doing. You may just want to take the speed and save yourself the trouble. In Handmade Hero, we're always talking about a little area. And so it makes sense to center everything around a real area and then piece them together. But if you're doing very disparate sort of, I want to talk about two people sitting here and here, both of them looking at something billions of miles away, you know, maybe just go to doubles at that point, because why not? Now, you still need the chunking, because you can't have all that stuff in play at a time, but you might, at a certain level of complexity, it gets to the point where the doubles are worth it, probably, because now you don't have to think about it anymore, right? And taking the speed hit of going from floats to doubles, all of your computations work on half as many values now, unfortunately, but that hit may be worth it. And you want, you know, you need to take into account, when you're making a decision, the costs of choice of coordinate system. And sometimes it makes sense to be localized, and sometimes it doesn't. Again, because of the structure of the universe, I would still say that probably the right thing to do is to have like chunks that are kind of separated discretely. But yeah, because there's nothing in between them, you know, and the players can't continuously drive from one sun to another, because they'd never get there. They have to engage like a warp drive or something, right? So you have to kind of think about what that game is really even about first. Would these massive distances even be needed if you don't need to be accurate to, say, the nearest centimeter, or do you always need to be that accurate? Well, again, I don't know, right? It was a hypothetical question posed without context, so I can't really tell what you would or would not need. But I mean, let's take the example of Handmade Hero as a context and say, for some unknown reason, and I don't know what that reason is, someone wants to make Handmade Hero Generations, the game where every Handmade Hero map is actually just a planet in a giant universe of like millions of planets, right? In that case, the chunk dim system I would just keep exactly as it is, and you would just end up going into space travel mode and warping yourself to some other planet, which loads in a new chunk world, right? That's definitely the right way to do that. And it may be the right way to do it in a 3D game about space travel as well, because like I said, this is 3D, so it just depends on what you're doing there. If you actually want to be able to fly anywhere continuously, though, you have a problem, and so you have to decide how you want to address that problem. It's a little weird because since the player can never actually fly everywhere continuously, it's a little bit weird to go to doubles and then do that, but it may still just be easier than coming up with exactly how you want to do it, right? But the long and short of it is just you have to always remember that floats have very little range. They can express, or very little accuracy, I should say. They can express very large numbers because they're in exponential form, but they're very inaccurate. And so it doesn't take very long at all before you will find your floating point values are totally not accurate enough for whatever you're doing. You know, even just if you're talking about like people running around on a planet's surface, even just a few kilometers down the line, it will start to become problematic, right? You know, at 20 kilometers, let's say, you'd already be in trouble, I would suspect. I would suspect. Don't quote me on that, but I suspect. When you wanted to sit there and be like able to look down at something at your feet and not have your feet be like jittering around or something, right? So it doesn't take very long for floats to go bad. And so doubles just offer a lot more. They cross the line into a much higher accuracy space for the kinds of numbers you might be caring about. And whether or not they're sufficient for a whole universe, I don't know. They probably aren't, to be completely honest with you. Like, I would suspect that doubles will lose accuracy if what you really wanted was like, oh yeah, like, I can stand on Earth and look at my feet, or I can go out to 3 galaxies away from here and look down at my feet and not have it jitter. I have never thought about whether a double's even enough. You know, it just might not be for our real universe. You know. Dan's idea. Do you always have to take float precision into account, or is it more like it will come up type of thing? You don't always have to take float precision into account. For games of a reasonable size, you know, the traditional level size in games, like think Doom, you know, or Call of Duty or something like that, it's just not an issue, right? Even The Witness, it wasn't an issue. That was just a separate bug, right? So you really don't usually have to take float precision into account until you get to bigger worlds. Something 10 times the size of the witness island probably starts to be a problem, right? So again, it really depends on how big of a single continuous area you want the player to be able to explore. And if that is roughly the size of a typical game level feeling thing, you will not generally have to worry about float precision in most circumstances. Sometimes it may come up due to certain things you could do or want to do that create particular stress on floating point, but most of the time it's not. So it really is about world size, and if you know ahead of time you're not caring about that, you don't have to worry about it. On Handmade Hero, we wouldn't probably have had to worry about it. I just wanted to show how to do it because I thought it's important that people were aware of it so that they would know. We may never make worlds that are big enough to care, but I wanted to make sure we could because I wanted to show that. I wanted to teach how that's done. Long billion. In this hypothetical situation, I suppose you could also change the physics realism of the universe so that planets and galaxies are closer than they would normally be, so flying to them is more feasible. That is exactly what I would do, right? If I was in charge, I'd be like, look, the universe is a really boring place. No offense, astrophysicists, but like most of it is empty. That's not fun. And usually what you end up doing is you just introduce like hyperspacing around, and so you never really fly around it. I'd say, yeah, screw it. All the planets are like 15 feet apart, right? Not 15 feet. I'm joking. All the planets are 100 miles apart all of a sudden for no darn reason. And so I can just take off of one and just go straight to another and land on it, right? Like real quick like. Yeah, absolutely. That's what I would do, not engine-wise. I'm totally, if someone tells me my goal is to make an engine that supports the full-size universe, I'm chuffed at that. I'm like, let's do it. That sounds good. Even if I have to use like a hierarchy of doubles to make that happen, I'm on board. So I'm fine with that. I just don't think it's very fun, right? That doesn't sound like a lot of fun to me. And so I would question the design of that. I don't know that I want to play that game, but I don't have a problem with it. So yeah, but in terms of the fun of the game, I'd say make them close together, you know? Let the player get there. Dan Zidane asks a question about the witness. Yes, exactly. So if we had a problem on the witness with float precision, we absolutely would have done exactly what we did in Handmade Hero, right? We would have just partitioned it into some sections because, again, we don't really have to worry too much in the witness about allowing floating point. I mean, you can't even shoot projectiles in the witness, right? It's a good case for partitioning. So that's what at least that's what I would have done. I don't know. Maybe John feels differently. Is the rather nice state of anti-aliasing in Handmade Hero have to do with use of depth peeling, or is it just standard MSAA? It's actually both of those two things. So we use multi-sample anti-aliasing and depth peeling to try and produce a reasonably high-quality image that has anti-aliasing on the sprites and on the hard geometry edges. So... Mr. Jake from State Farm. How do you tackle this issue in a large open world then? Do you use some sort of grid system? Well, like I said, Handmade Hero is, we solved it in Handmade Hero. The worlds can be as large as they want in Handmade Hero, really. There's no way to make a world in Handmade Hero large enough that the player could actually get to all of it and have it break our system. So we introduced one very specific way that you can do exactly that. That number of meters, it was 23 times a billion meters. So 23 billion meters. You could have a world in Handmade Hero that was 23 billion meters wide. And the player moves at the speed of a human, roughly, through it. So we're talking about like the distance to Mercury or something, right? Oh, that's miles. Never mind. what's the closest planet? Venus? All right. So you could get a quarter of the way to Venus easily without using any precision in our system. You could even go double that, really. So you could go half the way to Venus. Oh, and you could go in either direction. So now that I think about it, actually, yeah. So you could have a world in Handmade Hero that stretched effectively from Earth to Venus. And that's how big the world was. So we solved this problem in Handmade Hero. It's done, right? The player can't possibly explore as much of a world as we could create. They'd die long before they ever did. So we've solved that problem. I'm talking more about the hypothetical case the person was asking about with planets and a solar system, which has different constraints because there's a lot of empty, it's very sparse. And so at some point you may need to take a different approach due to the sparsity, because you would introduce a mechanism like warping, which would allow the player to get from one place to another much more quickly, which would mean that that distance they covered would be different, right? What benefit does depth peeling bring to the anti-aliasing table? So what happens is sprites, if you draw sprites into a world, the sprites themselves have anti-aliasing built into them, right? Because when the person painted them, the edges are basically, encoding some coverage information there. Does that make sense? So when you go to draw that sprite into the world, if you want, multi-sample anti-aliasing unfortunately doesn't quite have enough samples to really help you there. We tried that, I think, and it didn't look great. So what you want to do is you want to actually draw that anti-aliasing in order to help produce a nice smooth edge around your sprites. And so the depth peeling does that. That's what the depth peeling does. All right, looks like we're roughly done here, I think. All right, let's close it up. Glad we fixed that unproject call. That's a good thing to get right. Thanks everyone for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you'd like to follow along the series at home, you can always pre-order the game on handmadehero.org, and it comes with a source code so you can kind of track it as it goes and play around with it yourself. We will be back tomorrow, at which point I would like to start taking a look at the other issue we have in terms of smoothing out that initial play there, which is the camera motion and the simulation center changes. That's a little bit more of a sensitive issue, and we have to make sure we get that right. So that's the big thing I want to be focusing on tomorrow. And then we'll be back again next week to start looking at those that other part I was talking about, which is getting some of that art in there so we can start to look at what the world's going to look like. Because the last thing we really want to do is start to tune that lighting as part of the generation process. And tuning the lighting is going to require we actually have some art in there to look at what the game is going to look like. So we kind of got to bring all that stuff together. And again, part of that process will also be deciding what we're going to do with the perspective when it comes right down to it, because we really don't know exactly how we're going to work around some of the problems that could come up with that perspective. And so we'll see. Part of that'll be art on the art side. Part of it that'll be on our side, and so we'll have to see. We will have to see. All right. So that's about it. Thanks so much for joining me. Hope to see you back here tomorrow. We will be an hour earlier tomorrow, so be aware of that. If you came today, you got to come an hour earlier than you came if you want to catch it tomorrow. That's about it. Until next time, have fun programming, everyone, and I'll see everybody on the internet. Take it easy, everybody.